So we're going to get started because we are already running late, and I don't really want to cut any of the next talks short because they all promise to be really interesting. Well, welcome to the second session of today. And the theme is about food genome and sort of like online aspects of the food field. And the first speaker today, I think, is the physical incarnation of this conference. Mark Powell is actually a chef. He's a cook, so he has the very deep knowledge on the food industry. But he's also a hacker and a geek, so a very technical person, which is the other side of this conference. So I don't know, I wish I was like him in a sense, so I could have more authority on the food part of the conference. He's been going to present to us the work that he's done on hacking the food genome. He's been working with food sporting for a while, but before that job, he was a chef at the Fat Duck restaurant, right?
The research lab.
The research lab, and he's located in San Francisco. So please join me in welcoming Mark to this very interesting talk.
Hola, hola, ¿está bien? Hola, ¿cómo estás? Bien, bien, bien. ¿Cómo estáis? Estáis, gracias. Who here is a computer person? Raise your hand. Computer people. And who here is a food person? Raise your hand. OK, there's overlap. So welcome to my talk. My name is Mark Powell. I work for Food Spotting, which is a mobile food app, and I'm a food hacker. And I'm going to tell you about hacking the food genome and show some science fiction visions for culinary informatics. I speak very quickly, and there's a lot of slides to get through. So feel free to raise your hand and wave at me if you want me to slow down, and I'll probably ignore you. Slow down. OK, so this is the talk. You may ask, what is food hacking? What is the food genome? What is culinary informatics? Well, I'll tell you that first part of the talk is talking about the history of food hacking and food software and the problem of data. And the second part is my solution to data, which is the food genome. It's a software project of mine. And lastly, I will describe the science fiction possibilities for the future of what it becomes possible when you quantize food data. So a little bit about me, just as an introduction. Wow, down arrow. First, I will introduce myself. My name is Mark Powell. I live in San Francisco. I'm a hacker chef. I have a culinary education background. I've been to cooking school, sushi chef, worked at the Fat Duck research lab in 2005. I've written computer software for 2 decades and food software for 6 years. I live in San Francisco at the Hacker Kitchen of the Unicorn Precinct 13. I've worked at restaurants, mostly do catering. And I'm affiliated with various groups of American political activists and hacker activists. And I come from the hacker background, the computer hacker background. I spent a lot of my childhood breaking laws on computers. And so this is the perspective that has influenced cooking for me. Some of the projects I'm working on is since 2005, food hacking. After working at the Fat Duck, I wanted to present a computer hacker's take on molecular gastronomy. In 2008, I started this culinary informatics database for visualization called the Food Genome. And now I work at Food Spotting, which is a mobile software for visualizing restaurant menus and finding the best thing to eat. It's not restaurant reviews, it's just pictures of food. And I will go into all these in detail. So the first slide is food hacking. So what is food hacking? So I come from the computer hacker background, and after working at the Fat Duck, I thought, how do computer hackers look at cooking? Well, you have open source recipes. The previous speaker is saying that there is no copyrights for recipes. It's partly true. You cannot copyright the list of ingredients, but you can copyright the prose. So there's a lot of open source issues with that. Hardware hacking is making interesting devices. I have a lot of friends who build large devices and things like that. We have kitchen hack labs, which are laboratory experiments. And the goal for that is really reverse engineering of cuisine. The idea of you take a dish and you reverse engineer it and find out how that works. That's a very hacker morality, is taking something apart and finding out how it works. And then really that's going towards developing an algorithmic approach to food, where you have an algorithm and you are able to ask the algorithm, I am diabetic, and I love Thai food, but I hate peanuts. what is the algorithm that helps me eat at a restaurant, right? And then that algorithm, once we develop that algorithm, turns into the possibility for food software, which is software. So the open source recipes always evolving. Everybody copies from everyone else. The previous talk talked about this a lot. The copyright issues do exist, but they're largely unenforceable. Hardware hacking. This is a bicycle-powered espresso machine that my friend made. You pedal it, and it makes espresso. And you can go to the middle of the desert and make espresso. And it's very nice. It's steam-powered. Some other devices we've made are vacuum-powered sieves that take vacuum pumps. This is all food hacking projects. Bellagio bowl. It's like a fountain, like the Bellagio fountain, but with different colors of food in it. And home freeze dryers and centrifuges are very expensive, and so I like to build them at my house because it's much cheaper. Some other kitchen projects are kitchen hack labs. When I worked at the Fat Duck in the research laboratory, who here knows what Wikipedia is? Well, in 2005, we made a Fat Duck Wikipedia called Duckipedia, and it was all of the research information that had gone into a software. So these are some slides down here from, that's distilling Joselito ham, that's melon in a centrifuge, and that's confiture de mandarin right there. And the key here is that you're taking these laboratory results from a control group in the variants, and you're putting it into wiki software for other people to read it and contribute to culinary knowledge. So Hacker Kitchen. As a food hacker, I drive around the United States to my friends' kitchens and bring this molecular gastronomy technology to my friends who are very poor and can't afford to eat in fancy restaurants. And so there's been 4 food hacking tours around the United States and Europe and Asia where we have gone to people's kitchens, and it's very hands-on. Everyone kind of, we bring all of our scientific equipment and create things there so that people can have hands-on experience with sous vide cooking and centrifuges and freeze drying and things like that. So reverse engineering cuisine. As a hacker, I like to reverse engineer MP3s, DVDs. Every good cook does this. They decode a signature dish. They take Ferran Adria's, what is it called? Percebes de montagne, the mountain Percebes, right? And then try and reverse engineer. How does he get that texture, right? And so this is a hacker technique as well, where you have an algorithmic harness for fuzzing these ideas of food. And so how do you actually do this? Well, I'm getting to that. So the algorithmic approach to food requires food to be data. It requires it to be quantized. All the data has to be enumerated and have a taxonomy. And then you can feed it into genetic algorithms that spawn 1 million variants and evaluate the fitness function. And the fitness function is this a good food? So you make 1 million salads and take the most delicious one, and then use genetics to evolve that to the next generation of salads, with also health fitness functions as well. So I'm also a software developer. Who here writes computer software? Raise your hand. OK, well, the nice thing about computer software is it lets you express yourself. You create a world that other people can use to express themselves. So I built a lot of food Twitch games, online food games that have offline food consequences, and maybe even answer the question, what should I eat for lunch? And then you pull out your iPhone, and you say, what should I eat for lunch? And it tells you to go to this tapas place across the street. Also, will this food kill me? And putting your dietary restrictions in a software form. These are all just different possibilities that, as I was going through food hacking, realizing I needed a software platform to build software that would help me actually build this food stuff. So this is one of the first pieces of food software I built called Delicious Corpse. And it's a surrealist game. Do you know the surrealist game Exquisite Corpse? Raise your hand if you do. No? Well, it's a surrealist food game, and it just takes random foods and pieces them together in a menu. So you can see liquid nitrogen sesame soup, partially hydrogenated chicken breast milk. Right? And so you could just generate this over and over and over again, and it would create weird food. And it's surrealist, so it breaks down the barriers between you and what you think is possible. That's the whole point of this surrealist technique. So I'm going to talk about some other food games I built. This is a food game, tile game like Scrabble, where it helps you associate different, you play with like 3 other people, and you put down carrot, fig, ham, and then someone else says, OK, ham, raisin, maple syrup. And then someone else says maple syrup, pancakes, cheese. And so it just helps you break down and kind of gamify food in a way that gives you ideas of what to cook. This is a game from the 1980s called Shanghai, where it has these food tiles on it, and it really is just helping you look at the food. But if you look at the tiles, they're all kind of grouped down by count and by color and by shape. So it's kind of helping, it's like the game memory. It's helping you remember the number of things and the count of things. So this is very inspiring. As I'm looking for food software to build, I'm inspired by existing examples of periodic table of the elements of food. There are hundreds of these on the internet where they say the periodic table of vegetables, the periodic table of condiments. These are some other inspiring ideas from food software. This is the El Bulli taxonomy for, it's a visual taxonomy for that Ferran has, I think, in the second book for indicating food groups, right? So you have, there's vinegar, which is very similar to wine, except, well, you can actually see it on there. And then this is a visual cookbook. So this is where I kind of draw inspiration from, is other people developing languages of food, like that one talk was. So food software, in 1995, this is how you ordered a pizza online. And if you put mushrooms on it, or peppers on it, or cheese on it, it would visually appear. This is written by a man at Sun Microsystems in 1995. This is one of the first instances of real food software. This is the Synesthetic Cookbook Hugo Liu from MIT built in 2005. And he fed a lot of data into an engine and had all these adjectives and foods and combined them together. And so you can ask it, what is my mother? You know, what's healthy? What's rich? And it would come up with suggestions like these little fortune cookies. And this is a cookbook from 1950 called Wolf and Chef's Clothing. And it's just visual recipes, right? It's showing you that it's 1 spoon of vinegar and 1 cup of beer and all these slices of cheese. They're trying to get rid of words, right? And so this is the idea of a wordless recipe. These are all possibilities for food software, right? It's the idea to visualize a recipe without using words so much, right? And let's see. The next is the aroma wheel. This is another inspiration. This is built at the University of California, Davis. It's for wine pairing. And you say, what does the wine taste like? Well, it's green flavored. Well, is it dry green or fresh green? Oh, it's dried green. Oh, it's dried green. Is it tea or tobacco? And all these have different relationships. And this is very copyrighted, which is kind of one of the weird things about food data is it's very proprietary. No one wants to share. And this is the USDA nutrition database. These are all just ideas for visualization for the next part of the talk, where you're visualizing proteins and nutrients and things like that. And this is also very hard to copy and paste into some other food software. It's very hard to scrape this data. So with food hacking software, you have these 2 problems. I wanted to make food software in 2006, but there's no food data, and there's no physics model for food to be able to reverse engineer a recipe. The data doesn't exist yet. If it does exist, it's proprietary. It's in a corporate database, and I can't see pictures, and I can't visually model recipes. So the second part of my talk is about the food genome, which is my attempt to solve these problems with an open source food taxonomy. The problems are food data gardens. Everyone has a different taxonomy or schema of data, and nobody wants to share it. The next problem is that taste is subjective. I don't like what you like. Chinese food is different in Spain than it is in San Francisco, than it is in China, than it is in Sichuan region, than it is in the northern parts of China. And the third is that taste is visual, right? It's really hard for computers to look at 2 pictures of sushi and find out what is the most delicious one. But that's why where our brains kick in. Human computation speeds that process up. And so we want kind of a visualization platform. So these are the problems. So the food genome is an open food taxonomy. It's a software platform. You can have a personal flavor profile. This is what I like, don't like. It has geographical and diet filters and a visualization interface. So this is a visualization of the food genome. We have the colors of all the food on the right and kind of the food groups on the left. And you can kind of click through it and make a profile of the food that you like. You can say, I like eggs. I don't like peppers. I like olives. I don't drink wine. And then you can export that flavor profile to other food software. And then that other food software will know that those are your preferences, right? So it's a canonical data API. There's food physics, there's color information, there's dietary restrictions. I spent 3 years scraping data off of websites to kind of feed into this food genome through this API. But not everyone likes to share their data, so there's the ability to have a walled context to say that, well, this is just data from let's say food spotting or El Bulli, so no one else can share that data. So it's the ability to have walls inside your garden. So this is the kind of the physics model of the food genome, where you're able to convert mass to volume as purchased units. You can see here 1 head of garlic is 12 cloves. This is kind of the engine that we offer for the API. I'm just going through a lot of ideas of the food genome right now. This is the scraping interface where we have these parts of speech in a recipe. So you say 4 red onions cut lengthwise, and it recognizes 4 as a quantity, red onion as a product, cut lengthwise as a preparation, into as a special stop word, and the granularity is half-inch crescents. And so I've scraped hundreds of thousands of recipes and fed them into this so that we can kind of reverse engineer recipes a little bit. This is the food genome platform map, and you can see all the objects. This is kind of what the talk about El Bouy was describing, was the ideas of parts of speech or objects or classes. There's a technology, there's a preparation object, there's a food object, there's a region object like Spain. Food is like olive oil. So the food genome scrapes in all this data and then makes it available to query, so you can ask it, what are the red foods that they eat in China, right? Or what are the vegan foods you can eat in Thailand? It has a query interface based on all this data. So you can ask the genome a question, or you can tell it something. You can tell food genome, in England, I like curry, but in the United States, I don't like curry because there's no Indians there. So this feeds into what, once we scrape the ingredients from a recipe, we actually get the process of a recipe, which is the part that can be copyrighted, right? It's the prose, where you say, first crack the egg into the bowl and whisk it, and then pour it into the heat, to the heated mold. So this is our recipe pipeline, where we're able to take the ingredients and the directions and separate them into recipe steps with buckets and statements. And you know that when you're caramelizing the onions and you deglaze the onions, well, it's going into the default bucket. I'm going to keep skipping forward to the problem number 2, which is subjective taste. This is the idea of a personal food map. What are the foods you like? What are the foods your kids like? What about when you're feeling sick? So you can train it via a yum yuck. This is kind of a like, don't like interface. And you can also train your food allergies and then ask it, what can I eat for dinner? So you build a flavor profile like above, and you have yum versus yuck. And so imagine if everyone used the food genome, you would go to a website and say yum on lasagna, yuck on salad. You're always kind of teaching it so that you can build your flavor profile, which on the right up there is represented by colors of food. So this is kind of what I should eat for dinner based on different recipes that I've liked before. It kind of comes up with angel hair pasta because I want to eat tomatoes right now. Food allergies. Peanuts will kill me. What if you go to another country and they put peanuts in your food, but you don't speak the language? And so with the food genome, you can have your allergy in there and have internationalization plugs so that you can hold it up to the cook, and it says in their language, in Arabic, peanuts will kill me, right? So the second problem of taste is that it's subjective geographically. Iranian Persian food is much different than diaspora Persian food in Los Angeles, for example. And Chinese food is everywhere. I lived in Mexico, and you have broccoli and rice in Mexico, but also pinto beans, right? Because it's Mexico, and you have to put pinto beans and everything. And the whole point of this is to kind of visualize the taste gestalt geographically. So here you have a hierarchy on the food genome of what are all the Asian countries, and you can kind of query against this context. What would I like in China? What would I like in North China? And what is Iranian food? We have all these subregions of Iranian food, like Nowruz, the holiday cuisine. But this is all, and a general rule, this is food that you find, according to the food genome, in Iranian cuisine. So the third problem, now I will talk about food spotting, which is that taste is visual. You eat with your eyes, but computers don't have eyes. So you have to use computation in the human brain to find out the answer to what is delicious, right? So the color of food is something the food genome has. You can look up the color. Eggs are white and yellow. Celery is green. Peppers are red, yellow, and purple and red. And you can look at the colors of food, and it's really an indicator of health. Because if you eat too much white food and brown food, it's not very good for you. But if you eat green food and red food, there's more antioxidants. There's these more pigments in these healthy foods, which are better for you. And so you can see here a food genome on the bottom right, where it's evolving with time what you eat. So this person's pretty healthy, but then they have a lot of white food, so maybe not so much healthy anymore. Now I'm going to talk about the trippy food mandalas, which is this visualization that shows you what you eat the most, but it's also what's the most diverse, right? So this is this idea of where you can look at different countries, and you can say, China has a very diverse food because of that cone in the middle, but Singapore, according to this corpus, isn't as diverse. Thailand is way more diverse, and Korea is less diverse because you can grow less things there. And at a glance, this is the visualization platform of the food genome. You can look at all of these recipes and just know that this one's better for you than the one on the left. That one has cheese and mushrooms, and this one has lettuce in it, so it's probably better for you. So this is my diet growing over time. At the beginning, I eat a lot of brown food, and then I realized I should eat more red food. So the colors represent the different foods you're eating. And then once you have the colors of these foods, you can actually plot on XY graphs the food that you're eating and corpuses of recipe data. So for example, this is salty recipes versus sugary recipes. So this shows all the food that goes good with sugar this is the top is food that goes good with sugar, and the bottom is food that doesn't go good with sugar. So at the top you see eggs and milk and flour, and versus salt, which everything kind of clusters around the middle. So I'll show a couple of these. I call these food genome star charts. So this is butter versus olive oil, right? And so the food that goes better with butter is at the better with olive oil is at the top, and that's better with butter is at the bottom. So you see like candy things right here. Time versus time. This is all the food that goes with time versus itself. So the food that doesn't go with time is like over here, like cucumber and sherry wine vinegar and cranberries. But up there is more, vegetables, traditional time things. And so the food genome is an open platform. Anybody can ask it a question. And so my friend made placemats based on countries, right? I think I might have another. Well, it's a placemat based on the star chart of American cuisine. This napkin is all the food in America, all the colors, and then this is American food on it. And she did this for French cuisine, for Spanish cuisine. I think you can actually buy these somewhere. So artists are taking the food visualization aspect of food genome and making it. And now I'm going to talk about food spotting. So who here has used food spotting? Raise your hand if you have. Couple people, right. So it's mostly the United States, actually mostly in Asia. It's strange because Asian ladies are 80% of food spotting. And I think it's because culturally, Asia had cell phones with cameras on them 20 years before everybody else. And I remember being very embarrassed seeing some Chinese ladies take a picture in a restaurant in 2008. And now, less embarrassing. So food spotting is a visual menu for restaurants. You can't ever say anything negative on it. You can only say something positive. It's elegant, it's ubiquitous, it's on Facebook and Twitter and Android and iPhone and BlackBerry. Every restaurant should be using this to showcase their chef's creations, and a lot of restaurants are doing this. Because you can look at a restaurant and think, should I go here? And if you don't want to read through a lot of reviews, you just want to swipe through and see pictures of all the food. And the nice thing is there's some really good pictures of the food here. This is a pizza and a green tea cake and a hamburger. The people who are using it are great photographers, and you really get this idea of what kind of food you should be eating. So there's hundreds of thousands of photos, and a lot of them are gorgeous. And everything has a latitude and a longitude. So this is data that's being added into food spotting, right? So I'm the iPhone programmer on food spotting. I've written the software for the past year. So this is a real-time feed in food spotting of all the food that people are eating everywhere in the world right now. This is with latitude and longitude. You see this person in London just had this burger board. This person in South Korea just had ondong, which I have no idea what that is. And it's very multicultural. In Sydney, this person just ate that. So because you have a latitude and longitude, I hooked this data up into the food genome and then looked up the colors of all the food so that I could actually visualize food spotting data by color, right? So the top one is where all the food in food spotting has been eaten. You can see it's concentrated a little bit in the edges of Asia, some in Europe, mostly in the United States. And then the second one is latitude and longitude of the colors of food. So you can see the eastern part of the United States is not very healthy. It's a lot of white food and brown food. There's some corn down in Mexico. There's rice along the sides here, and then pork and beef and things like that. And then I think this is New Zealand or Australia. So maybe they're eating kangaroo color, right? So this is the idea with food spotting, is that you can have the latitude and longitude with food. How am I doing for time?
You have 5 or 7
Got
minutes?
it. No worries, no worries. So now this is the last part of the talk. How's the talk going? Yeah? Is that all right? Good. All right, so the third part is science fiction visions for culinary informatics. Who likes Star Trek? Raise your hand. Star Trek is very inspiring. They had the first cell phones on Star Trek. They teleported people on Star Trek. A lot of science fiction drives technology, right? So the first idea is that is what are culinary informatics? So culinary informatics is what I'm going to describe right now. It's a common data standard with a visual vocabulary that allows you to do subjective taste queries. So culinary informatics is a way of looking at all the food data on the planet and saying an olive in Spain is an olive in Europe, and these are the possible colors of olive. And when you chop an olive, it's a solid, so you can chop it. But you can't chop balsamic vinegar because it's a liquid unless you freeze it first. And it's a visual vocabulary. You know the color, and you have pictures of olives. You can do subjective taste queries. You can say, I don't like olives. What should I eat that makes me like olives? And then it can look up and say, well, I see you love Hawaiian food and you love pineapples, so why don't you have a pineapple olive barbecue shish kebab? And see if that makes you like olives, because I think olives go with pineapple. And then you can rate it and give it feedback of yum or yuck. And so once we have this system of culinary informatics, this database of all the food physics and data, we're able to actually assign computer science techniques to that and make operators and math and actually build culinary algorithms, right? And the culinary algorithm is, if there's a fitness function of how much water something uses, like a melon, a cantaloupe in Israel uses a lot of water, right? And so if you have a fitness function in the algorithm saying, decrease water usage, maybe that can actually, you can feed a bunch of recipes into it and it can rank them with an algorithm and say, well, here are the recipes that use a lot of local cuisine that doesn't use a lot of water. And at the bottom is things that are exporting or that are importing fruits and vegetables from places that don't have a lot of water. Then you get into this idea of culinary programming languages, right? Which is what I'm very interested in. Once you have the algorithms, you have the programming language. And the programming language is like that game Burger Time. It's like you stack sausage on top of cheese and have this idea of, it's like a formalized vocabulary. I have more notes on this. Hold on a second. It's a formalized vocabulary that allows you to actually make really interesting things. And then you have the programming language. You evolve it to a culinary operating system. And once you have a culinary operating system, well, then you have science fiction. And what kind of science fiction? Oh, well, first, let me explain what I mean by quantizing food. So this is a food genome algorithm that takes a recipe and splits it up by its words into a sentence diagram, where it knows that all of the vegetable stock, we have all the root vegetables up there, onion, carrots, and it roasts it, and it gets added to the stock pot with all these aromatics for the bouquet garni, and then you're adding water and simmering and straining. So what you can do when you quantize this is you can say, well, I don't have cheesecloth. What should I use? And it says, oh, use a strainer or use pantyhose. Or you can say, here, I don't have a lemon squeeze to add to this rhubarb syrup. And it says, oh, well, you can add apple cider vinegar. So when you quantize food data by parts of speech, you're able to kind of break it up and do a substitution for recipes. So this is the we and adjusting proportion. So when you have a culinary programming language, you're able to take a recipe and say, this recipe costs too much. It needs to cost a lot less. And it replaces the percebes with arroz, right? It gets rid of the really expensive ingredient and replaces it with a really cheap ingredient. Or you say, this is too many calories. I need to reduce this a little bit. So it replaces the butter with olive oil. Or this takes too long. And you reduce you slide the time down and you say, okay, we'll just buy chopped garlic instead of chopping the garlic yourself. And the me is here because this is this interface where you're given 12 possibilities and you can go from page to page. And so I want to see this for recipes, right? Where you say, well, here's the vegetarian version and here's the artichoke version and here's the seafood version of recipes. So this is possible with culinary programming languages. Every recipe becomes possible. Not just the million recipes there are on the earth. You can take a recipe like French onion soup. This is an early food genome prototype. You can slide it. You can click on France and change it to Moroccan onion soup, and it'll put orange zest and cumin in it. Or you can change it from a soup to a sandwich. So you have French onion sandwich, and it'll take the same ingredients and try and form them into a sandwich. It'll take the beef stock and soak the baguette in it with Gruyere cheese, and then put caramelized onions on it. So every recipe kind of becomes possible, breaking it down. So when you talk about science fiction, you have utopia versus dystopia. Utopia is like Star Trek, good. Dystopia is like Soylent Green, bad. Everyone's eating each other and cannibals and things like that. So first I'm going to talk about some utopias. This idea of a kitchen holodeck, right? This is a virtual kitchen where you have an interactive kitchen training with a virtual sensei. So I went to sushi school and I had a sensei, right? And I can look up on Wikipedia what's right about sushi, but my sensei is more right, because I agree with my sensei 100%. So it's an augmented reality environment in a kitchen with microphones and camera that listens to what you're doing, because cooking, you cook with your ears, actually. You put a sausage in a pan and it should go psh. It shouldn't just go, right? If you blend something, you can tell how fast something is being blended or how slow something is being blended. So this is the kitchen holodeck is a vision for the future, which is this, it's kind of like an interactive video game in your kitchen, and you get points for cleaning. Like every time in a sushi bar, when someone wipes down the counter, they get a point. But then you get a demerit for wasting water if you leave the water running. And so this, I think, is a positive utopian vision. The next utopian vision I have is food replicators from Star Trek. Raise your hand if you know what a replicator is from Star Trek. So you go up to this console and you say, I want tea and I want it hot. You say tea Earl Grey hot, or you say tea Earl Grey cold. It's listening to what you're saying, all right, and creating it. So now we're going to talk about the dystopian visions, the matrix, right? The taste matrix is when you have a programming language for food, you're going to have a transmitter hooked up to your tongue that relays computer. And when you're not using your tongue, it'll actually, the central database will run flavors by you and say, is this good, is this good, is this good, is this good? And the genetic algorithms will be used to develop new flavors for super rich people. And then your tongue will be all busted and numb, which is really unfortunate. So this is another dystopian vision for the future, which is kitchen gladiators, which is every restaurant is online right now. And so what if every person who blogged and tweeted got to decide what this kitchen made? And they said, no, you need to put more salt in it. No, you need to put more lemon in it. And kitchens would be pitted against each other to the death, right? right? So this is kind of a bad possibility for the dystopian vision of culinary informatics. And so this is my epilogue and the end of my talk, which is the morals of food technology. And I think Kenton hit on this a little bit, which is you have to ask yourselves, what are the offline health outcomes of your technology? Are you giving people diabetes? Is it killing restaurants? And who owns the data? So a positive health outcome, a bad outcome is you're sitting on Facebook clicking on a croissant 8 hours a day. A good outcome is you're learning something new and then you go try it. And a great is, oh, well, this helps me save money because I'm not wasting water and helps me clean and manage resources. You don't want to let your food software users get diabetes because then they won't be there. So in food spotting, we have deep fried butter and a salad, right? And so this is this idea that you can see this and it looks really delicious, but maybe it's not so good that we get people to eat that because it really kills them and hurts their heart. Please don't kill restaurants. Groupon and Yelp in the United States are these food 2.0 companies that are killing restaurants. Yelp reviews destroy restaurants because people are very negative about it. Restaurant marketing budget, a speaker earlier, or audience member asked about this. Restaurant marketing budget is very precious. And so every new idea, you say, hey, give me $200 a month and I'll put you on Facebook. It's killing that restaurant, right? We should not be making money off of we should be making money off of the diners, not the restaurants. And the third thing is who owns the data? Well, first, your personal diet is medical data, which is covered in the United States under privacy laws. And if you control the taxonomy, it controls the universe. Imagine Google just bought Zagat. Imagine if Google controlled all food data, right? The food data is ours. Everyone should open your data. That's it. That's my talk. You can get in touch with me on Twitter. And that's the talk. That's what do you think?
Thank you, Mark.
Yeah.
Any questions for Mark? Is the presentation available?
Find me later. I'll give it to you. Yeah.
OK. If there is more interest, would it be possible to make available through us, for example, if there are more people interested?
Okay. Yeah, sure. If you're, yeah, sure, you can do that.
Any other questions? Sebastian?
Do you find that restaurants contribute to food spotting themselves, that they photograph their own dishes and put it up?
Can you repeat the question?
Yeah, so he says, do restaurants contribute to food spotting? Yes, restaurants and groups of restaurants. So there's a great British chef's feed that I follow that's all the best restaurants in the United Kingdom that are showing pictures of their food. There's a restaurant in Chicago that has a food spotting table where if you refer yourself as a food spotting person, it has really nice light for you to take pictures, and you get to sit there and they make a special menu for you.
Wow.
So some restaurants are taking advantage of it.
Any other questions? I have a question for you. So how many food ingredients and items are there in the food genome?
There's like 1,800.
1,800.
Yeah.
And how vast, sort of like how you think this covers most of the recipes?
I think it's a lot of United States recipe websites right now. It's very United States centric.
Okay.
So please contribute to the food genome. Find me on Twitter as Mark Codes and ask me questions.
Okay.
Thanks
Thank
very
you,
much.
Mark.
Yeah.